here, like you just say, I will give you a noise function, or I will give you a sine function, or I will give you a static function. So for example, so it's like basically it just compiles a new, it compiles a new unit every time we build the function. So that's all, and then you stack all these parameters together, and it allows you to, well, suddenly build some kind of pretty things. So if we go, so if I take this one, for example, we can see it from here. Yeah, you can see, like, basically you start, this one starts from this geometry, then it's like, then I add one first extrusion pattern. I will show normal instead. Yeah, that's a bit easier to visualize. So you just basically, yeah, you just stack operators. So progressively, like, and you can, well, you can design, you can change parameters straight away directly in your editor. So you're just stacking operators, and then you, I really love to start from really mini primitive and to do something really fun out of it. So like starting from a triangle or a cylinder or just a sphere is like, and you just apply a lot of different patterns and you create something interesting out of it. So a bit, well, you can do all your modeling by hand, but you can also do it by function. I prefer the former way.
How do you do it so that you don't end up with fucked up geometry that's got fleet faces, bad normals?
Well, I calculate it myself.
Yeah, yeah.
So like internally you have a lot of data structure which I calculated for you. The idea is when I'm on the editor, I really don't want to deal with that shit actually. I really don't want to deal with bad normal. I don't want to deal with bad light. So the tool internally calculates, like it calculates the normal, it makes sure all the winding is correct. So as soon as I push my operator, everything is fine. So like there's a lot of data structure which are calculated, like every time you add a new generation, there's a lot of data structure so you can do selection, and a lot of things are calculated behind the scenes that we don't see. Like, but...
Because sorry mate, if you do this sort of shit in C4D and you add loads of deformers, you know, effectors and all this shit,
yeah.
And you go really abstract, it's great, but you end up with shitloads of flip faces and bad normals and all sorts of...
Yeah, well, I try to as much recalculate as possible. That's the main idea.
Even Maxon can't do this right, mate.
So it's like, for example, if I take, yeah, the idea is really to have something done really nice, but you need to have the, yeah, there's like all these tasks we don't want to redo every time. Like, for example, if I take examples of particle system, like I'll show a bit of the code for mine. I really don't want, like, there's a lot of data structure which are calculated from emitters and everything, but I don't, like, I should not put a node, recalculate my offset. That like the user should not have to do that explicitly. So I try to have as much implicitly done. So at the end, I just end up doing things instead. So if I take particle, like, so here it includes, yeah, so for example, just for the particle thing, you have, like, it's just, like, actually, the main thing now with the card, like, also I try to design the data. So I design data, and then I deal with it. So it's a bit of a functional approach if you know about programming. Like the functional way is like you design your data. Like I think object-oriented programming sucks somehow. It's really bad. It's really like, I mean, it's cool, but you're really far from your data. So I really try to always design close to my data, and functional makes much more sense. Like I have my data structure and then I have functions. So actually my function doesn't care if I'm, for example, using my position is a buffer here, but it could be a texture. My function does not care about it. So it's much easier to replace things if you start to make a clear separation between your operations and your data. And object-oriented programming is the quite opposite of that. You try to couple your data with your process. And I think it's much, if you want to decouple, it's better to use some form of functional type programming, which shaders do actually really well. When you look at compute shader, it's like, run this n times. It's like an embedded loop, and it's like a function. And it's much more efficient, it's much more cleverly done. So yeah, like for example, particle system, so you have initial position, velocity, force. You have the standard collision, selection, because you can also decide, like for example, apply an effector to only a subset of your particles. And you have all the optional attributes like color, edge, size, normals, emitter ID, rotation. You have all the collision data. But the great thing is after, when we start to think functional, actually most, like for example, like a gravity effector is resumed to just this. If you take a gravity effector, it's like take this number and add it to the force. So instead of doing all this coupled or object-oriented like shit tons of boilerplate, you can really resume things with like function. And I use, I don't know who knows, this library export. So you have the HLSL library export, so I can reflect, basically I can reflect the function. So anything which takes float3, in the reflection is eligible as a force field, for example. So that means I have this reflector internally, so instead of having to write all that horror boilerplate, I just write a simple function. So for example, if you take this one, that's for velocity map. So if you want to say add velocity x, y, to do displacement, you just end up, everything is resumed to a simple function, which I like when things become a bit more compact, let's call it that way. So instead it's like grabs any function, like if I go back here.
Pretty much back to the Uber shader concepts. Again, we include everything.
Yeah, like basically I have one shader which I do a dynamic include. So I have one shader which knows what to do and holds all the data structure and knows what to do, but it doesn't know how. And then the function tells the how. So then I kind of mix them and it compiles the shader automatically. So it's like you have this what and how, and I try to really separate it. Like for geometry you have pattern, for particles you have functions. But like a lot of my tooling works like that. It's like I really like to separate the what and how. So that's why I like this clean separation of data. Like pretty much, and you can build you have this linker function, so you can also build your own, you can compile your own shader, like grabbing functions together. So for materials, for example, you can build your own material. It compiles the shader on the fly directly. Like actually, I can show one probably here. I need to clone desktop because it's gonna be really horrible to try to do something from here straight away. And Yeah, well, you can also directly compile your shader with function straight away. So if you need to do...
You can go in depth step by time.
Hmm?
Much more wondering about the UI. You can go in depth step by time and saying I'm opening that node, create a more complex one in that other tab.
What's the what, sorry?
Yeah, I had the feeling you were creating a node in your root,
Yeah.
and then you went to the shader patch, and
Yeah.
you went a bit more in depth into that node. That's right?
Yeah, just...
Yeah, okay.
Okay. Yeah, it's just basic navigation, really.
Okay.
Like, well, normally I should have the little color to tell, but this one does not. Normally I like little subtle coloring to just say this can be opened, for example. Yeah, and well, yeah, you have the obvious other things you ever need. So yeah, you have like, you need to have well, video playback. So that's like the, if you need tooling, you need video also. It's just like, it's, well, it feels really hard for some people, but it's like kind of fairly obvious. Every time you will have to do a project, you need a timeline and video. That's the number 2 first thing you need. So yeah, I did HAP and DXV native. So, well, they're actually 99% similar anyway, so if you can do HAP, you can do DXV. I had a little quirk, so I had to rewrite the QuickTime parser from scratch, because otherwise on Windows it's complete chaos to do that. So, but it's not really a hard work anyway. So yeah, like actually playing video is okay. The exporting is an absolute pain in the ass. I really hate export. Because with like playback, you can really ditch everything you don't need. Whereas when you export, like this player might expect this data to be here. So you always have to put everything needed. Like, and QuickTime format is really shit, really, I have to say. Sorry for insulting, but this guy, I've never seen something that badly done. It's just everything makes no sense. Everything is represented differently. It makes 0 sense. It's like, okay, this number is this format, this number is this format. Why? It's just a stupid number. And why do you ever want to do that? I think this guy really, I don't know what he did, but I don't really want. It's like all this really horror legacy. Actually, I got my old file format, which is called SCO. It's called for stupid container. So my grandma can write a player from it in 5 minutes. And yeah, I really, yeah, well, it's really, I will not start to go on video so much, it's really horrible. Like graphics are much more fun. So yeah, I'll show, well, I guess I got some other example. Actually, I can show the, yeah. Yeah, there's a couple of other bits, well, that we use, I can speak about. Yeah, so the main thing is, yeah, actually, compilers know, like I'll show a couple of, you always end up also doing this like kind of random tricks, I think. Every graphics programmer could write a book about that. How did I abuse the pipeline in an unexpected way? I'm pretty sure Matt is an expert on that. So yeah, it's always like sometimes like when something tries to be smart, it starts to sometimes also be on the way. So like for example, DX11, like the compiler, I can show some horror code. Hope you don't mind. Like for example, if I take this one. So yeah, you need also a bit of, well, one thing you generally need badly is like compositing. That's like the most standard. Yeah, you also need your general compositing. So if you, like if I start that one. Yeah, I know I have.
Just advertising ASAP to the internet.
Okay, this one takes time to load. Yeah, you also need some form of compositing, like just a standard blending. So I use like this, what's called type UAV load to do the, like, you can do tons with standard blend unit. Actually, it's a bit like blend on stencil are a bit undervalued to my taste, but generally I use, well, I do the same concept with includes, and you have your blend functions which can use mask or not. And it uses type 2 AV load, which allows me to save on resources. So I can use one texture and write in place into only one texture. So type 2 AV load. You have to do the packing yourself for uint because it's not allowed in DX11. But if you're on Windows 10, you can do it straight away because they allow it for channels. So you have plenty of these mini tricks that you always have to do. Like my most hated one is like when I have to, like this one is the worst. Yeah, that one is the worst thing you have to ever do. It's like I use this, you can use this UAV at every stage, which is pretty awesome. Like I use that a lot for my geometry system nowadays, because I can use, you can use tessellation. That's not what I need. You can use tessellation and write to structured buffer with tessellation. Write a tessellator engine in compute because I'm lazy. And since there's already one which is done for me, I might as well use it. But the problem is then, for example, you end up in this situation. Like I tried, if you comment out this line here, like I say, just push me my triangle on the GS, but then the compiler will tell you, hey, you're not emitting anything because you're not calling this append. And so the compiler starts to be like saying, no, you're not allowed to do that, whereas I'm totally allowed and I want to do that and I can, but the compiler says, no, you don't. So I tried, I said to do something like to put something like if 200 greater than 100, like that. But the compiler is too smart. It will actually know that this is always true, so it will actually remove the line. So that means it's too smart from you. It's a really smart ass, and it then removes that code and still says to me, no, you did not push to your geometry. So I had to create a dummy variable here, so the comp, which I initialized to 0 and say, if this dummy variable, but because the compiler doesn't know the value, then it will let me do what I want, finally. So, but you can still nowadays, you can do that, but it doesn't work on every place. You have to use you can use tiled resource nowadays. So I actually it was designed to use like huge terrain or like super data streaming. And obviously I had to find a use which was not designed for. So actually we can use that for overlapping resource. So basically a tiled resource is a resource with no memory. So you allocate memory after. So I can create a bulk of memory which is for my vertex and my structured buffer, and then I create the resource pointing to the same place. It's like how to do simple thing in a complicated way. Like at least with new modern pipelines like Vulkan or DX12, we don't have this limitation anymore, finally. We just say, this is my bulk of memory and do whatever the hell you want with it, which is pretty great. So tiled resource is also really, I use it also heavily for post-processing. So everything which is shared, like for example, any intermediate things that I don't need, like anything that I need within a function, like for example, depth of field, I need 3 intermediate buffer. I will use tiled resource to share it across everything. So that's also a pretty cool feature for that. And you can, it's like grow only memory, so it's not, you don't have to recreate everything all the time. So it's also pretty nifty feature. that people did not plan to use for that type of usage, but never mind. So I'll show one other example, and I think I can. Okay, actually, do you have? Actually, it's already 50, so I think I'm more or less done. So, do you have questions, or do you want to see another example? Or? Another example. Okay. I somehow guessed. So.
My eyes bleed. So
Make your eyes bleed. Okay.
I know you can. I know you can.
Okay. Let's see then. Well, I got quite a few, but this one takes a lot of time to load.
Takes more time finding the actual fucking Python code in it.
Yeah, this one is a very slow load up. Ah, there we go. Yeah, actually, I can show complicated a bit more. So that's the one I use for VJ normally. So it has all the, you can have the generative scene. You have like 8 layers of video content, and it has all the UI thing here. So here. Okay, so it's probably a bit fast thing. But yeah, you have all the composite modes. So here you have all the mixers, just like has all the mods you need. It does all this really memory allocation, and everything is kind of optimized around. And actually every scene can also have their own UI. So like if you take, for example, this here. So every scene has their own user interface block. So for example, if I say here, when I have my patterns here, like if I take here, like my patterns, I can also configure everything straight away. So I can build you. If I say no, I need this or this, it's also automatically dynamic. So you can. So the idea is also you need to do like complicated 3D, but for most time when I do festivals and things, people want minimal content. Like you don't need to do all the crazy shit all the time. People are super happy with scanlines sometimes. You have to be also, actually you have to be very, like, because you also have people doing the light, so sometimes it's a bit, everyone wants to do their own shit at the same time. So the light guy wants to blow as much light as possible, the graphics guy wants to blow as much graphics as possible. So it becomes a bit of a soup. So, but if you start to, so that's why you try to do a bit more minimal content, because it's also easy suddenly to change color to something like blue. So if the guy puts some like, for example, orange light, I will put some blue because I like orange and blue. So, but with minimal content, it's a bit easier to deal with that. If I have a full-blown scene, like 3D crazy scene, I can't do that. It's like, actually, I can't even really compose it. I just play it or don't play. With like minimal content, you can more easily compose, obviously. So yeah, most of the bits are like just generative, or I can choose video on top. But so it's like, yeah, also having a bit of UI to control your thing, because most of the time when you do a show, you have to operate during the show. That sounds kind of what I was speaking to my friend when I did this big bank project last year. I was actually fixing the show during that's the fourth major bank in France. Annual show where they show how nice they are, and I was fixing the show in the middle of the show, which was not very fun. So it's also like for modern pipeline, we also need a bit of UI. We need to operate something. Like if you're in a festival, you will always also have a type of, like you will have the, everyone who did festival will know this promoter coming with this stupid USB stick on these really shitty pictures. And can you please put my logo, or can you put my very badly compressed video? Like the guy will arrive with this 3 gigabyte crap move file 3 minutes before the show, obviously. And when you start to say, well, it needs to copy, and he's starting to shout at you because the USB copy is not fast enough. So yeah, well, outline of say, you also really need to have a bit of operating. So UI, there's also some parts of UI saying, okay, I can quite rapidly integrate this video and generally press play and go drink a beer. And watch as the screen as less as possible. Because when people arrive with a 3 gig file, the quality of the content is generally beyond horrid. So, well, anyone got questions? So, thanks for listening about this. Thanks.
I've got a question.
Yes.
I just wondered more about like where do you get your inspiration from, your ideas from in terms of the content? Because you've gone into a lot of detail about
Actually,
and stuff, but your work is very kind of natural. It's using a lot of technology, but actually a lot of for me anyway, the stuff.
actually, I do it the reverse way, I would say. Like, actually, I find a new cool math technique, and then I try to do graphics out of it. So actually, most of those, it's like I found this new programming concept, which was kind of fun, and I try to make something looking cool out of it after. So it's not, I'm not trying to do something cool directly. I try to do something cool with code, and then I try to make some nice graphics after. I know it's a bit reverse, but that's like that.
Code. Code, amazing. But what excites you, like looking forward and new work and projects? What things are you excited by? What technology?
Well, I'm still, well, personally, I really continuing to work. I really love tooling. Like, tooling is really the fun things for me because, I mean, we can replace a lot of things. Like, we have a lot of render technology, but I really like the fact of doing something for the process of creation, like having a bit of UI, being able to change parameters. And I really like the tooling concept is a bit undervalued sometimes, I think. And whereas I think for me it's actually the most powerful part. So I'm still really interested in going forward in tooling, doing more advanced. And I just like graphics as it goes, really.
What's your sort of favorite kind of collaborations? You showed a piece at the beginning that was like an installation, permanent installation project.
Well, that one I could do a talk of one day about it and the chaos going about it.
Is there particular kind of other disciplines or artists or art forms that you would like to collaborate more with, or what's your?
Well, I like mostly any art form. Like, yeah, well, music industry. I'm not always big fan. It's always a bit tricky. Like, depends who. I like small labels, more independent people in general. Like big, like music stuff. It can always be a bit tricky. Let's call it that way. But, well, you always have really cool small studio and producer where you can do really super nice things. But I like to collaborate with music a bit. It's because obviously, well, generally when we do a piece, we like to have music on top of it. Like it's like we generally when we play graphics anyway for festival or installation, we're on top of the music. Like the star is the musician.
Do you think that will change going forward in the future? Like what?
No, I don't think so. I think if we go for festival, people don't come to see a visual guy; they come to see an artist. Well, an artist. They come to see a musician.
Good point. Want to see you. That's why we're here.
Yeah. Yeah, but I think the day I will feel Glastonbury during a talk, I don't think it will be for tomorrow. Sorry. I think
Cool. Well, thanks a lot. Is there any other questions, or anyone got any?
When's this tool actually coming out? When do I get
I actually expected that question around. Well, there's some planning around, but it's still planning. So, like from the point of doing something from yourself, for yourself, and the point to have something for everyone, you have a gap. But, well, this gap is getting somewhere, let's call it that way.
Thank you very much. Okay, there'll be a little break, and then we have Mangosh. Evil, is that your name?
Yeah, that's
Evil. Pure evil. In the after lunch.
After lunch.
Hopefully no sacrifices will be made.